Monday, I uploaded a video explaining 3 concepts that we use when we are considering measuring or counting atoms. That is 1, the mole, 2, Avogadros number, and 3, molar mass. These 3 concepts together can be put together in 2 different conversion factors. That's what I want to talk about in this video. Now, I just uploaded the video on conversion factors in general, how we use a ratio between 2 units that is equal to 1 to change from 1 unit to another unit. So I want to relate that back to the video on Monday and talking about Avogadro's number, the mole, and molar mass. So first, looking at Avogadro's number. This relates the number of molecules to 1 mole, and that number specifically is 6.022 times 10 to the power of 23. That is the number of molecules per 1 mole. Now, because they are an equal quantity, 6.022 times 10 to the power 23 is equal to 1 mole. If we multiply something times this conversion factor, we are essentially multiplying it times 1 because these 2 units are equal. And remember, in math, you can multiply things times 1 because it doesn't affect the actual number. The only reason why we do this is because we want to change from 1 unit to another unit. I do want to point out that it doesn't have to be molecules. It could also be atoms, depending on if in the question if you are given atoms or molecules, but either way, it's the same. I do also want to emphasize that molecules is not equal to moles. I do not want you to abbreviate molecules as MOL because MOL is 1 mole. This is 1 mole. That is different than MOL. That's different than molecules. So I just want to do a couple of practice problems with this one by itself. I'll do another video relating to molar mass, and then I'll do a third video which uses both. So what if I say how many atoms are in 2 moles of gold? Okay, because gold is an element which contains atoms. It is not a compound that contains molecules. So there is a set way that I want you to solve these problems, and it will serve you every single time. It is one set procedure that can work, for all of these problems. The first thing that you have to do is identify the data that you are given in the question. For chemistry, it's almost always a number and a unit of something, because for the most part, chemistry problems are about converting from 1 unit to something else. So you want to identify what unit you're given and the quantity of that unit. So in this case, we are given 2 moles of gold. Okay, once you identify that, I want you to put that number and unit on the left-hand side. So I've got 2 moles of gold, right? Gold is AU. The second thing you want to do is identify what is the unit you're being asked to convert this unit into. And it's usually preceded by how or what. So how many atoms? That is the unit that it's asking me to convert moles into. So then what I want you to do is leave some space for the conversion factor or factors. And on the right-hand side, I want you to write the unit that you're trying to find. Now, the reason why I tell you to do this is because sometimes you're going to need more than 1 conversion factor. So what I want you to do is to set up, I guess it's flipped for you. So this would be the left and that's the right, whatever. I'm just going to use from my perspective. So on one side, you want to have where you're starting, and the other side, you want to see where you have to go. Because a lot of times when we get more into practicing these kinds of things, you're going to have multiple steps. You're going to say, okay, if I start with this, I can go to B, and from B, I can go to C, and from C to D, and so on. So you need to see a pathway there. For now, it's just going to involve one or maybe two conversion factors, but later on it might get more complicated. So based on the unit that I start with and the unit that I'm asked to find, I'm going to use this conversion factor for Avogadros number, and I'm going to multiply this times my conversion factor, which is 6.022 times 10 to the power 23 atoms per 1 mole. And now you see I've got mole on the top here and mole on the bottom here. Another way you can write this out, if you want to make it more clear about what you can cut or cancel, you can do 2 moles of AU atoms over here. And instead of doing a multiply sign, you can just draw a line like that. And then you put in your conversion factor. So that might make it a bit more clear as to what you can cut, moles and moles, up here, mole and mole. So by the end of it, the only thing that you're left with, the only unit that you're left with that is not cut is the unit that you're being asked to find. And then you go like that. There we go. Okay, let's see. So I've got 2 times, how do I do this? Let's try 6.022 times 10. Yeah, hey, that worked. So then you end up getting 1.2 times 10 to the power, that's E, times 10 to the power 24. So if I make 1.2 times, oh shoot. Okay, sorry, I got a delivery. Where was I? So 1.2 times 10 power 24, 24, and then let me get rid of this. Whoop. Oops. Let me, take that one. Ta-da. Okay, so then that's your final answer. All right, so you take all the numbers that are at the top. You might want to start using this notation method first, or just stick with that. I learned doing it just that way. Either way, it's exactly the same thing. Let's try another one, but let's try something in a different format. How many moles are in 3 molecules? Wait, if I can write. Come on. Molecules of water. Okay, so again, you want to first identify what data you're given in the question, the number and the unit. And you probably want to practice identifying the substance as well, because later on we will change substances. So you want to have the qualifier for like the 3 molecules of what? So on the left hand side, 3 molecules of water, and identify the unit that you're being asked to convert that into how many moles. So moles of water goes on the right hand side. I'll just do it this way. Now here's one problem. If I just put in my conversion factor, and instead of atoms, I'm going to use molecules this time. Now, the problem is that you notice that molecules, boy, what was that? Hello? Okay, I just won't use that then. I'll just use that. Molecules, I'll use that either. What am I gonna do? All right, molecules, hello? There we go. Molecules and molecules are both on the top. So if you treat it the way that you treat variables in math, like your X and Y, and you've got molecules times molecules divided by moles, the unit that you're going to end up with is going to be molecules squared per mole. That didn't make no sense. That's what my nephew says. They don't make no sense. So we don't want to do that. And in fact, because these two amounts, I really wish I had a laser pointer in notes, but anyway, molecules and moles, these are both equal to 1. So we can switch them around. So instead of having molecules per mole, because I want to have molecules on the bottom of the conversion factor so that it can cut, I want to have molecules down here. So my 6.022 times 10 to the power 23 goes on the bottom and 1 mole goes on the top. You can do that. You can switch it around. So again, I'll do the calculator. Oh, I forgot to say something, but I'm going to mention it after this. So 3 divided by 6.022 23. Does that work? Nope, that don't work. 3 divided by 6.022 times 10 power 23. Okay, so what I wanted to mention is, I'm just going to write this number down here so I can use that as an example of what I wanted to mention. Okay. I forgot the most important part when it comes to coming up with your final answer. I want you, before you move on to the next question, which I did not do because I forgot, is to check your answer and see if it makes sense. I know that you've studied exponents, so you should understand somewhat what your answer should look like. So if you look at 2 times 6, the 6 times 10 to the 23, so you know 2 times 6 is 12, but you should remember scientific notation from teacher Vanessa, so you can't use 12 times 10 power 23, so that's going to become 10 power 24, 1.2. So this answer makes sense. Now let me go down to what my calculator just told me the answer to this question was. So I have 3. 3 divided by 6 times 10 power 23. And the way that I put it in my calculator is giving me 5 times 10 to the power 22. That should not make sense because you know that 10 power 23 is on the bottom, which means that you're subtracting it. So you should have a 10 to the power negative something something, right? 23, 22, something like that. It should be that. So this is what I mean by check the answer to see if it makes sense. It doesn't make sense. And the reason it doesn't make sense because I don't know how to put it in my calculator app. Let's see, mainly I'll use brackets. When in doubt, use brackets. So 3 divided by bracket, 6.022 times 10 x to the y 23 and bracket. Yeah, and see now you see on my calculator screen 6.022 e 23, the e is equal to times 10 to the power. So that I know was entered correctly. Now I just press enter. Ha, there we go. That makes sense. Hello? Oh, because I'm on the eraser. Shoot. How do can I move? Can you move that? Like, no, fine. Okay, so that was 5 times 10 power minus 24. Can I shrink that? No, okay, fine. So that goes in there. So 5 times 10 power minus 24 moles of water. That number makes sense because you've got 10 times 10 to the power of 23 in the denominator. So your exponent needs to be supremely negative. These are the kind of things I want you to watch out for. And these are conversion factors with just Avogadro's number.